Hey everyone, my name is Andile and welcome to Trigonometry. The section that we're going to talk about in this video is going to be area rule, sine rule, and cos rule. Please don't skip this intro as it is very important. This video covers everything that you need to know to get a minimum of 60% and above in this section of the paper. It is very important that you watch the video in order. Why? Because as we move along, we're going to come across some concepts that I've already explained earlier in the section. So I won't be going deep into them again. They've already been broken down properly before. So there is no need to repeat as already I've explained it in a deeper sense. So now the video breakdown. The video is divided into 4 sections. Section 1, the area rule. Section 2, the sine rule. Section 3, the cosine rule. And section 4, how to determine which rule to use. This video is pretty long, so to help you out, I've added timestamps in the description. You can use them to jump to specific parts if needed. Again, right? Just very important. Only use it to jump into sections if you already know the fact that the previous sections you already understand. If you don't understand, make sure the fact that you go in order. As I said, the fact that everything is a build up. Hope that makes sense, right? So with that said, we can start with the video.
Welcome to sine, cosine, and area rule. So the first thing that we're going to do is we're going to talk about the proof for area rule, right? But at the end of us doing individual, which covers the sine, the area, and the cos rule, instead I'm going to show you ways on how to identify which one to use. But now, what we're going to do is we're going to do the proofs because they are very important for examination, right? So now the first one is called the area rule, right? So the area rule, when do we use it? We use it when we are given a triangle and that triangle is not a right angle triangle. And since we know the fact that it's easy to find the area of a right angle triangle, this rule that we're about to prove right now, right, is another way to find the area if you are given a triangle that's not a right angle triangle. So with that said, what we need to do here is that we need to prove this, then we're going to do questions after that, right? So let me just change my pen into being blue. So the first thing that we need to do is that we need to create a construction. So from this point here, which is P, we're going to draw dotted lines, right? Creating a point here, and that point we're going to call it S, right? Then that dotted line, when we go down, is going to create a right angle. So what's going to happen is that this line PQ that we just created is going to be perpendicular to what? To QR. So since we did some construction, that's the first thing that we're going to do. We're going to write the fact that we did construction. So I'm just going to say construction because that's the first thing that we did, right? And we're going to say what? Draw PS, which is, that's the dotted line, right? With S, at where is S? S is lying on where? Is lying on QR. So with S on what? On QR, right? So S, do you see the fact that it's on QR? But we know the fact that such that what? That this PS, the line that we just formed, is perpendicular to QS, right? So you're going to say comma, such that PS is perpendicular to what? To QR, right? So basically we created two right angle triangles, and the reason why we did that is because we're going to use those right angle triangles to basically do what? To basically find the area of this whole triangle, which is this situation, right? So we're going to name this PSH because that's the height, right? So that's the height. So now remember the fact that we need to prove the area, right? So this is what we need to prove, and I'm just going to highlight it so that you guys are not confused. I'm just going to highlight it. This is what we are required to prove, right? So we're required to prove this, right? So what do we know from the information that we know? We know the fact that since we created a right angle triangle, is that we can write the area. So we know the fact that in normal instant, right, the area of this triangle, if we're not going to use this one, is going to be what? So we know the fact that the area of triangle PQR is equals to what? Is equals to half base, right, times height, right? So that's what we know, right? We know the fact that the area of this is going to be half base times height, right? So with that said, is that what do we know, right? We know the fact that it's half base times height. Looking at our triangle, what is our base? We see the fact that our base is this, and I'm just going to highlight it. I want to change my color. My base is this. You see that? So that's my base, right? So we know the fact that the base is equals to what? Is equals to QR, right? So we know that the base is equals to QR. Do you see the fact that looking at the base and looking at what we need to prove, we already have QR. So we're one step close. So what do we know now? We need to find, so we have the base, we have the half here, and we have the half here. So now what do we need to find? We need to find the h, right? Which is the height, right? So what do we see? We see the fact that if we take, because do you see the fact that the other portion of our part that we need to prove, this portion, it says sine Q. So we need to use this angle here, right, as being our reference, and we need to find the sine of that. So let's find the sine of Q, right? So I'm taking this, so we know the fact that it's going to be opposite over hypotenuse, right? So we know the fact that sine Q is equals to opposite, right? So opposite is h, and hypotenuse is PQ. Remember the fact that we want to get rid of this h, right? So this h, we want to get rid of it. So we're going to make it the subject. So we will make it the subject. It's going to be PQ, right? And it's going to be sine Q, right? Is equals to h. Do you see the fact that h is equals to exactly this? PQ sine h. So we know the fact that h is equals to that. So therefore, we can conclude that the area, right, of triangle PQR is equals to half, and the base is what? Our base, remember the fact that this is our base. Our base is QR multiplied by our height, which is PQ sine Q, right? Do you see the fact that it's exactly like what we want? It's exactly like what we want. So that's how you would prove area rule. So now what I want to do is that I want to put the area rule into what? Into practice, basically, right? So what we have is that we have this, and it says the fact that we need to find the area of triangle ABC, right? So one thing about the area rule, you need to understand what information do you need from the triangle to use it, right? So, and I'm just going to take this triangle, right? And actually, let's go back to the proof so that I can see you, so that you can see what I mean, right? So you see that from the proof that we just done is that the area of triangle 1 over 2 QR multiplied by P is sine Q, right? Is that for you to find the area of the triangle, you need the following information. You need the following. You need to have two sides like this, right? And the included angle. Do you see the fact that that's what we proved? Is that there's two sides, which is Q, what you call this QR, and another side, which is PQ, and the included angle, which is this one, right? So this will find the area. So another thing that we could do is that if our angle is this, is this P, right? Is that it's going to be two sides in this included angle, meaning it's going to be like this. Do you see that? It's going to be two sides in the included angle. So if I had to write the area of that, it's just going to be basically going to be, this can be also written as the area of triangle PQR is equals to a half. I said two sides, which is my two sides is what? And remember, it's two sides and the included angle. So the angle needs to be in between the two sides, right? So it's going to be PQ multiplied by PR multiplied by what? By sine P, right? So that's 2 sine and the included angle. So now let's change it and make the fact that we want the included angle, which is going to be, let me just change my color into being yellow, right? Is that we want our R to be what? To be our angle. So it's going to be 2 sides, right? And the included angle. So the included angle is going to be this one, right? So to write the area, so the included angle is going to be this one, then the 2 sides. So the area also, you can find the area being what? Is being P, Q, R is equals to 1 over 2, 2 sides, right? Which is going to be P, R multiplied by R, Q. Then it's going to be sine R. So that's how you would find it, right? So with me explaining that concept, the fact that every time when we're looking for the angle, it's always 2 sides and the included angle, is that when asked to find the area of a triangle, right? And we know the fact that this is not a right angle triangle, is that we need 2 sides and it's the included angle, which goes in the included angle. So what do we see from our triangle? We see the following. We see the fact that our triangle is an isosceles, meaning if this is 7, and also that means the fact that this is 7, right? That's what we know. And we know the fact that opposite sides are equal. That means that opposite angles are equal. So this one is going to be what? It's going to be 50 degrees too, right? So that's what we know, right? Then what else do we know? We know the fact that the sum of angles in a triangle is equals to 180. So we know the fact that, so let's write what I just did, right? We know the fact that C is going to be equals to what? It's going to be equals to 7. And your reason is going to be what? It's going to be isosceles, right? So isosceles triangle, right? Then we know the fact that even if you don't write the reason, to be honest, is that now we know, because this is not the same as Euclidean where your reasoning is important, but I'm writing it so that you can know why that is the case, right? Then we know the fact that therefore angle C is equals to what? To 50 degrees. And right, so it's what? Opposite sides equal means that opposite angles equal. Opposite angles equal. Hope that makes sense, right? So that's what we know. So we know the fact that this is going to be 50. Then I said the fact that this we can find it by sum of angles in a triangle. So we know the fact that angle A plus angle B plus angle C is going to be equals to 180 degrees. And that's what? Sum of angles in a triangle. So sum of angles in triangle, right? Hope that makes sense. So with that said, we know the fact that we're looking for what? So it's sum of angles in a triangle. So now we know the fact that we can find A. So it's going to be angle A. And this is going to be plus 50 plus another 50 is equals to 180, right? Take that to the other side. So it's the same as A is equals to 180 degrees minus 100, which is A is equals to what? Is equals to 80 degrees, right? So this is going to be 80 degrees, right? So we know the fact that that's going to be equals to 80 degrees. So now remember that I said when you're finding the area, what do we need? We need the 2 sides and the included angles. Do you see the fact that we have 2 sides, which is this one, right? And before finding anything, we need to find this angle because this is going to be the only included angle. So the area of this triangle, so we know the fact that now area, let me write in the triangle first. Let me erase that. Okay, cool. So it's going to be the area of triangle A, B, C is equals to 1 over 2. Then remember 2 sides, which is going to be AB, right, multiplied by AC, right, multiplied by sine A. And that is going to be equals to 1 over 2. Then AB is 7. Then this is going to be 7. Then it's going to be sine 80 degrees, right? Punch that into the calculator. You find your area is going to be 24.13 degrees unit square, right? So I just want to talk about why didn't we use B as being the angle, right? So let me just take my pen. I just want to move to highlighter. Why didn't we use B as being the angle, right? So do you see the fact that we have the angle B? For us to find the area is the two sides. We have the included angle, meaning the two sides will be this and this. Do you see the fact that this portion is missing? We don't have this side. We only have one side. So we have one information missing. So that is why we couldn't use that. But do you see with A is that we had the two sides because of this information, the fact that it's an isosceles triangle. And we didn't have the angle. And us solving the angle, we know now we have the angle because of the sum of angles in a triangle. I hope it makes sense why we didn't use B, but we used A instead, right? So now let's do example 2. It says the fact that we need to show the the area of triangle DEF is equals to 1 over 2 DF then sine A, right? So first of all is that since we're given this, we need to understand which is the included angle that we need to do, right? So is that we know the fact that this is the included angle. Do you see the fact that this is the included angle? So this is going to be the included angle, and this are the two sides, right? So let me take my highlighter. These are the two sides, which is exactly what's written here, right? So using what we used in the proof is that we're going to use the fact that we know the fact that the area, right? Area of the triangle DEF is basically equals to half base, right, times height. So we're going to use that information. Then what we're going to do is that we're going to find the base and we're going to find the height. So we know the fact that the base, right? So we know in our case that the base is equals to what? The base is going to be this one, right? So we know that the base is equals to D. So that's sorted. So we have this and we have this. So now we need to find this portion, right? So for us to find this portion, definitely this portion needs to be what? It needs to be definitely this portion needs to be what? It needs to be the height, right? But looking at our triangle right now, right, is that this is not a right angle triangle. So I can't say opposite over hypotenuse. But do you see the fact that here, right? Do you see the fact that, let me just change my color. Do you see the fact that there is a right angle triangle here? So I can use sine in that aspect. And what is nice is that if I find sine of E2, right, instead of E1, is that F is going to be included. Do you see? And there's F here. So there's going to be a close relation to this F. I hope that makes sense, right? So with that said is the following, is that we know the fact that in triangle, this triangle, so we know the fact that in triangle DHE, right? And we're going to use this angle as being our reference because that's the E. Remember the fact that we need E, right? So we're going to say, we know the fact that sine E2, right, is equals to what? Is equals to opposite, which is H, over hypotenuse, which is F, right? Then we're going to take F to the other side because we want H to be the subject. So it's going to be the same as F sine E2 is equals to H, right? So that's what we know, which is great, right? So we know the fact that this is going to be our situation, right? So now we know the fact that what we know. So now we know the fact that this can replace H. So let's do that, right? So we know the fact that now, let me just write it here, it's going to be the area, right, of triangle DEF, right, is equals to what? Is equals to 1 over 2. Then it's going to be what? Then our base, remember, is D. Then our H is going to be F sine E2, right? But we know what? We know the relationship to find E1 because remember the fact that that is what we are looking at, right? At E1, not E2. We know the fact that E1 plus E2 is equals to what? Is equals to 180 because of that angles in the straight line. So now making E2 the subject so that we can get rid of it is going to be that E2 is equals to 180 degrees minus E2, right? E1, sorry, E1, right? So we know the fact that if we looked at the trig situation, if this is what? This is 180 minus, right? Then this is 180 plus. We know the fact that this is going to be the same as what? If we changed it, we know the fact that E2 is basically equals to E1. If we needed to take this into consideration, right? So since they are equals to each other, I can change this E2 as being E1, right? So we know the fact that this is going to be the same as saying what? 1 over 2 D if that is going to be sine E1, right? Which is the same as saying just E. Because now, remember the fact that for us to have the triangle, the yellow triangle, is that we created a construction. So this E1 is the same as being E if we're going to look at the triangle that we were given without constructing the H. Okay? So this is going to be the same as 1 over 2, right? Then sine E. So that's how you would do this question. So now moving to sine rule, right? So with sine rule is that this is the proof that we need to prove, right? So for us to do sine rule is that the first thing that we need to do is the construction, right? So the construction is that you're going to draw a line from P going down, and we're going to name this point S, right? So after us naming that point S, what we're going to do is that we're going to name this H, then we're going to write the information. So we're going to say construction, right? So you're going to say draw, which is the same thing that we did with area rule. So it's going to be draw P. We're going to say draw PS, not PQ. And erase that. Draw PS, right? With S1 QR, right? Such that what? Such that PS, right, is equals to what? Is perpendicular, sorry, to Q. Alright. So here we need to prove the fact that sine Q, which is here, right, divided by, so sine Q divided by what? So let's mark it. Let's mark our information. So we need to prove that sine Q, which is here, divided by what? By QR is equals to what? Is equals to, let me change my highlighter, is equals to sine R, which is this one, right? Divided by what? Divided by QP. So that's what we need to solve, right? So with that said, is that we need to basically find sine Q and sine R. Then for some is that they need to have something common that we need to equate. But for us to find sine is that we know the fact that we have two right angle triangles, right? So for this triangle, which is I'm going to highlight it in, I'm going to highlight this one in green for the sine Q1, right? And the sine R1, I'm going to highlight it in yellow, right? Do you see the fact that H is common in both of them, right? So meaning we're going to make H the common thing that we're going to equate the two. So we're going to take the area, which was we're going to take the trig ratio of sine in the yellow one and the green one, making Q and R the angles. I hope that makes sense. So let's do that. So in the yellow one, so I'm going to say in triangle PS R, right? We know the fact that sine R is equals to what? Is equals to opposite, which is opposite is going to be what? It's going to be H. So it's going to be H divided by what? Divided by the hypotenuse, which is P R, right? So that's what we know. Then what we're going to do is that we're going to make H the subject, right? So it's going to be PR multiplied by sine R. So that sorted is equals to H, right? Then we're going to say in triangle, which is the green one. So we're going to say in triangle P Q S, right? So we know the fact that it's going to be sine Q, right? It's going to be equals to opposite, which is H, divided by what? Divided by hypotenuse, which is in our case is going to be PQ, right? So make H the subject. So this is the same as saying PQ is equals to PQ sine Q is equals to H. Do you see the fact that both are equals to H? So I'm going to equate them together. So this is going to be the same as saying PR sine R is equals to what? Is equals to PQ sine Q, right? Then what we're going to do is that we're going to divide throughout. So we know the fact that here, if you here, we already here, right? So we know the fact that sine R is divided by what? By PQ. So we know the fact that sine R is divided by PQ, and therefore it's going to be sine Q is divided by what? By PR. Then that's you being done with the proof. Hope that makes sense. So now what we're going to do is we're going to do the first example of sine rule. But before we do the first example of sine rule, I'm just going to draw a triangle, right? Just a small triangle, not looking at this information, right? Let's say we have the triangle A, B, and C, right? And I know the fact that I'm going to talk more about it when I show you in different case studies on when to use which one, right? But for us to understand on how to solve this question, you need to understand which information do you need so that you can solve, right? So with sine rule is that always the angle is, if you have an angle, it needs to be related to its side, the opposite side of it, right? So this angle here, do you see the fact that this angle B is going to be related with this one that I ticked off? And also this angle B needs to be related with the opposite side, and also the C needs to be related with the opposite side. So with that said, is that if maybe we're looking for this AC, for instance, right? Let's say we're looking for AC. For us to solve AC is that we need to have the angle of what? We need to have the angle B. So this one needs to be given, right? So this needs to be given. Then another pair needs to be given, meaning it's either this and this are given, or it's either this and this are given. So there needs to be one unknown. I hope that makes sense. I feel like this is going to make sense when we do questions, right? So let's do this question. So it says, let me just erase this mess that I just created here. So let's just talk about it so that you can see it in action, right? It tells you the fact that triangle TRS, right, with the angle STR is equals to 55 degrees, and they tell you the fact that TR is equals to 30 units. Then they tell you that fact that RST is equals to 40. Then they tell you determine the fact that we need to determine this P, PS, ST, and this angle, right? So now let's draw the triangle with the information that we're given. So this is the triangle. And we know the fact that this is T, so I'm going to start here. So it's going to be TRS. All right? So they tell us the fact that this angle T, which call this STR, is equals to 55. So S is here. So we're going to go in this direction. So it's going to be STR. So they're talking about this angle. It's going to be 55 degrees. And they tell us the fact that TR is 30. So the side is going to be 30. Then they tell us the fact that RST, so going from this direction, it's RST is equals to 40. So they're talking about this way. See? Then now, since we're given two angles, we can find this angle because of that's going to be sum of angles in a triangle. So we know the fact that angle R plus angle S plus angle T is equals to 180 degrees. The sum of angles in a triangle. So we're looking for angle R plus angle T is what? Is 55 because we're given that. So it's going to be 55 plus 40 is equals to 180, right? Take the numbers in the other side. When we take the numbers in the other side, we find the fact that angle R, right, is equals to what? Is equals to 85 degrees, right? And we see the fact that angle R is the same as what? As TRS. Do you see the fact that it's this one? So therefore, now we already solved this one. We know the fact that TR is basically equals to 85 degrees. So we have solved the first part. So this is 85 degrees. So we have solved this one, right? So now we need to solve the side. So we know the fact that since we're given all the angles, we can find both sides, right? As I said, the fact that we need to relate it with the side. So let's start finding this side, right? So let's write this side, which is going to be this one, right? Finding this one. Then we know the fact that we need another pair that has an angle in the side. So we know the fact that we have 40 degrees and we're given this one. So we can solve using sine rule. So using that, we know the fact that sine is, right, divided by what? Remember the fact that it's the angle on the opposite side, which is TR, is equals to sine. We're looking for this side, which is going to be sine T, right, divided by what? By the opposite side, which is R S, which is this one, the one that we're looking for, right? So let's substitute all the numbers. So we know the fact that sine is what? Is 40 degrees divided by TR, which is 30. Then this is going to be sine by T, which is 55, divided by what? Divided by RS, which is the one that we're looking for, right? So cross multiply, so we're going to cross multiply. So when we cross multiply, it's going to be RS, then it's going to be sine 40 degrees, then this is going to be 30, then it's going to be sine 55 degrees, right? Then we need RS and also we're going to divide it. So it's going to be RS is basically equals to what? Is equals to 30 sine 55 degrees. And this is going to be divided by what? This is going to be divided by sine 40 degrees. Punch that into the calculator. When you punch that into the calculator, you find the fact that R is, right, is going to be equals to what? It's going to be equals to 38,2, right? So that is going to be the RS, right? So we have that one sorted. So now we're going to solve for what? We know the fact that this is going to be 38,2. So now we need to solve for T, which was T is. Do you see the fact that T is, and I'm just going to change the color so that I'm not confusing you guys, is that, do you see the fact that T is related to this R? Do you see? And with another side and the angle, you can use either or. So I'm going to still use this one as our reference, right? And the reason why is that we were given what? We were given this information, and this one is the new information. So if this one is incorrect, I don't want it to affect the other one. That is why I'm using another side that was originally given in the information. I hope that makes sense, right? So now finding what? Finding T is. So we know the fact that it's sine of this area and this one, right? So we're going to use sine of R and sine of what? Sine of S. So let's start. So it's going to be sine S, right, divided by what? Divided by R. T is equals to sine R divided by what? Divided by T is. Let's substitute. So it's going to be the same as sine 40. Now it's going to be sine 40 is divided by what? Divided by M divided by sine 40 divided by 30. Then the side is going to be equals to what? To sine 85. And this is going to be divided by T is. Cross multiply. So it's going to be T is. Then this is going to be sine 40. Then this is going to be 30 sine 85, right? And what we're going to do is that we're going to divide both sides by what? Divide both sides by side 40. So it's going to be the same as T is equals to 30 sine 85. And this whole thing is going to be divided by what? It's going to be divided by sine 40, right? Punch that into the calculator. You're going to get the fact that T is basically equals to 46,5. Right? So that's how you would do it. Now we're going to do example 2. It says prove the sine rule. right, of M and P, which is this triangle, not the one that is extended. And they gave us the fact that MS is perpendicular to NP. So remember the fact that when we prove sine rule is that always H is going to be the one that's common in between them. So that is what we're going to use here. But here, do you see the fact that it's not the same as this one, right? Is that our H is outside. But the nice thing is that we can use that relationship in terms of we can create two triangles. And let me just show you. We can use this triangle as being the first triangle where we can find our what you call this, the relationship with H, and the other triangle is going to be this one, right? It's going to be this one, the big one, right? So what I'm going to do is that I'm going to start with the big one because of it's within, the information is within the triangle that we want, and the triangle that we're talking about is going to be this one, which is going to be the blue one, because that's what we're proving the sine rule being relation with, right? So with that said, is that let's start with the big triangle, which is going to be the green one, with making H the subject, right? So we know the fact that, let me just change my color. We know for a fact the fact that sine, so we're going to use this P, right? So we know the fact that sine P, right, is basically equals to what is equals to opposite, which is opposite is H divided by N. And the reason why I'm using this P is that P is the only one that's going to give me sine in terms of it being opposite and hypotenuse. I hope that makes sense, right? So now we know the fact that H is going to be common. So we're going to say N is sine P, is equals to H, right? So we sorted with that one, right? So now we're going to move to the yellow triangle, which is the small one, right? So we know with that one, we can't use this N as being the angle, but we need to use this one, right? So that's what we're going to do. So we're going to say what? We're going to say the following. We're going to say sine of N2 is equals to what? Opposite, which is H, divided by hypotenuse, which is P, right? So we know the fact that we want H to be the subject. So it's going to be what? It's going to be sine. It's going to be P sine N2 is equals to H. But remember the fact that we don't want N2, we want N1. What do we know? We know the relationship between what? We know the relationship between N1 and N2. We know the following. We know the fact that angle N1 plus the angle N2 is equals to 180 degrees, right? So we can take what? We can take N1 to the other side because we want to make N2 the subject, right? So we're going to say N2 is equals to 180 degrees minus what? Minus N1, right? So if that's the case, and I'm just going to go back, I think I did it somewhere. Yes, here. Yes. Do you see the fact that here the relationship is that if we substituted back, and I just want to do this, if we substituted back E1, so here, and I'm just going to just do it at a different color so that I just want to show you why we said the fact that this is the same. So we see the fact that here, if we substituted N2 as being this one, right? As being this one, which is 180 degrees minus what? Minus E1, is that we know the fact that using the tree diagram, this is all students take coffee, right? We know the fact that in the second quadrant, sine is positive. So this is going to be the same as sine E1. So that is why I concluded into these two being equals to each other. And in this case, we know the fact that since we're looking at this triangle as being the E1, this is the same as having what? This is the same as just having sine E. So this is the same instant here, right? Instead, what we're going to do is that we're going to substitute the N2 by N1 by this one, right? So now replacing that is going to be the same as saying what? As P sine, and this is the same as 180 degrees minus N1, right? And this is going to be equals to H. But we know the fact that by using this, remember, in the second quadrant, this is the same as saying what? Let me just write it here so that I'm not confusing anyone. This is 180 minus theta, right? And this is all students take coffee. it's in the second quadrant, meaning sine is going to be positive, so the angle is going to be positive. So this is the same as sine n1 is equals to h, right? Do you see the fact that now we are dealing with the blue triangle because n1 is there and angle P is there. So if that's the case, now we're going to equate these two together. Let me just highlight them. Yeah, let me just know it's going to be liquid. Let me highlight. We're going to equate these two together because they both equals to h. So that's what we're going to do. So it's going to be the same as n sine P is equals to P sine N1, right? Then now we're going to get rid of what? We're going to get rid of the numbers that are the alphabets that are in front of it. Since this side is, is multiplied by n, meaning the side is going to be divided by that. So it's going to be the same as n, right? And here's going to be n, and this side is going to be p, and it's going to be p. So those ones are going to cancel out, and those p's are going to cancel out. So our answer here is going to be the same as what? It's going to be the same as sine P divided by P. Then this side is going to be sine N divided by N1 divided by N. I hope that makes sense. So that's how you would prove this question. So now we're going to move to example 3. Let me just change my pen color. It says there is a coastline with 2 lighthouses, one on either side, meaning is this one and this one, right? And they tell us the fact that one on inner side of the beach. Then they tell us the fact that the 2 lighthouses are 0,67 kilometers apart, meaning the fact that light 1 and light 2, this distance here is 0,67 kilometers, because they are 0,67 kilometers apart, and one is exactly on the east and the other one is, the other one is exactly on the east of the other one. Then they tell us that the lighthouses tells how close a boat is by taking a bearing to the boat, right? A bearing is an angle that measures in clockwise from north. Then they tell us the fact that those bearings are shown in the diagram. So this is that. Then now they tell us the fact that calculate how far the boat is from the lighthouses. So C is the boat. So point C here, this is where the boat is. Remember, this is where the boat is, and this 2A and B are the lighthouses, right? So now what we are given here, we're given the following. We're given the fact that this whole angle, do you see the fact that when they say angle A, they mean this whole thing? And let me just take my highlighter. They mean this whole thing, right? Is equals to this, right? So as for us to solve what is this distance and this distance, is that we need the angle that's inside, right? So, and also they tell us the fact that this angle here, the bearing, which is this one, right, is equals to this one, right? So now for us to solve, or how far is the boat from each light bulb, lighthouse, is that we need to solve the following. Let me change my highlighter. We need to solve for this side, right? Because that is the distance between the both, which is C and A. Meaning we need to solve for this side, and also we need to solve for this side, right? So meaning if we have a triangle, this is the triangle, which is the blue one, right? So we need those 2 angles here. This one that's inside, and we also need this one that's inside to complete our triangle, right? And I'm going to just draw it here separately. So now what do we see? We see the fact that for the yellow one, they gave us 100 and what? They gave us 127. And do you see the fact that this one, this is a 90 degrees? Do you see the fact that this whole angle A, right? Angle A is made out of 90 degrees, right? So we basically, to find this small angle is basically, we can say the fact that this angle here, right? So let's name it. Let me just draw the diagram here so they can make sense, because the other diagram is going to give us problem. This is A, this is B, this is C, sorry, and this is B. So I want this angle, right? We know the fact that the angle that's included that has this, right, has the 127, but we know the fact that there is a 90 degrees. which is I just indicated here, right? So to find this angle that's inside is the same as saying what? It's the same as saying 127, right? Minus what? Minus 90 degrees, right? So we are taking out this 90 to find this small portion. Do you see that? And that is going to give us what? 37. So this is going to be 37 degrees. I hope that makes sense, right? So it's that we already know that this is 90 and we know that the entire thing is 127. So since we know that the entire thing is 127 and we know that's 90 and the small portion that we want that's inside is what? Is this 38. So if you say 90 plus 38, you're going to get this 127. I hope that makes sense. So we sorted with that one, right? So now let's move on into the green angle. We see that we're given what? We're given that the outside is what? Is 255, right? But we know the fact that angles in a revolution is what? 360, right? And also we see the fact that this is also 90. So we're given that 225 plus this 90, meaning if we take the whole thing, if we say 360, because that's angles in the revolution, and we minus it by 255, sorry, right? Then minus that 90, which is here, this 90. Do you see the fact that we're going to get this angle here, right? And that's going to give us what? That's going to give us 15. So this is going to be 15. So 15 is going to be here. But what do we know? We know the fact that sum of angles in the triangles are equals to 180. So we know the fact that sum of angles in the triangle. So you know the fact that angle A, right, plus angle B plus angle C is equals to what? Is equals to 180. We know the fact that this is what? This is 37. This is 15. And we're looking for C. Is equals to 180. Take it to the other side. So it's going to be what? It's going to be 180 minus 37 minus 15, which is going to give us 128 degrees. So this is going to be 128 degrees. So we're done with this triangle. It's sorted, right? So remember the fact that since we have all the angles and we know the fact that the side is 0.67 because this is the distance between the lighthouses. So now we're looking for this and we're looking for this, right? Do you see the fact that we can use sine rule? And using sine rule is that it's going to be one side in the included angle. So now we're going to solve for AC, right? So we know the fact that AC, right? So finding AC, so I'm just going to highlight it like that or underline it. We know the fact that AC is related to B, right? So we know the fact that sine B divided by what? By AC is equals to, you can take what? We need to use sine C because of sine C is the one that has what? That has the opposite side to it, right? So we know the fact that sine C is basically divided by what? By AB. So let's substitute. We know the fact that sine B, which is 15, divided by what? Divided by AC, which is what we're looking for, right? Because that's one of the side. And this is going to be what? This is going to be sine 128. And this is going to be divided by what? Divided by 0.67. Cross multiply. So this is going to be, so it's going to be 0.67 sine 15. Then this is going to be AC. Then this is going to be sine 128, right? Divide both sides by sine 28. So it's going to be 0.67 sine 15 divided by what? Divided by sine 128, which is going to be equals to AC. So therefore, when you punch this into the calculator, AC is going to be equals to what? It's going to be equals to 0.22 kilometers. So the distance here is going to be 0.22 kilometers. So we're done with that side. Now we're going to look for this side, right? And I'm just going to do it here. I hope there's space. So I'm just going to do it here. So we know the fact that sine what? Remember the fact that we're looking for, because now we have this side, which is 0.22. We're looking for this side, right? So we're looking for BC. So we know that BC, right, is related to sine A. So we know the fact that this is going to be the same as sine A and sine A is related to B, C. And that's going to be what? Then we're going to use sine C and this one because of that's the one that has the side and the included angle, right? And the angle, not the included angle. So it's going to be sine C divided by what? Divided by AB. So we know the fact that sine A is 37 divided by what? Divided by B. C, which is going to be equals to sine 128 divided by what? Divided by 0.67. Right? Cross multiply. So this is going to be 0.67 sine 37 is equals to B. C, that's going to be sine 128. Right? So this is going to be the same as, there's no space. So this is going to be the same as having B, C, and this is going to be the same as saying 0.67 sine 37 divided by what? Divided by sine 128. Punch that into the calculator. BC is basically going to be equals to 0.51 kilometers. So this side is going to be 0.51 kilometers. And that's how you would solve this question. Now we're going to move to ambiguous case. So ambiguous case is the fact that if you're given two triangles, what can happen is that you can draw both the triangles different, meaning you can have two different angles as being different answers, right? So that is ambiguous case. And what happens is that the angle that you're looking for could be two different answers. So that's what we're going to do, is that we're going to draw two different triangles. But how we solve it is that we can end up having two different answers. So the first one, it says, let's read the information before I start drawing the triangles. It says in the triangle ABC, they tell us the fact that AB is equals to 82, BC is equals to 65, then angle A is equals to 50. Then they say the fact that we need to draw triangle ABC and find the angle C. So the first triangle could be like this. And this is going to be what? This is going to be A, B, C, right? So let's write the information that they gave us. They tell us the fact that AB is equals to 82. So the fact that this is going to be 82. And they tell us the fact that angle A is equals to 50 degrees. So this is going to be 50 degrees. And they also tell us what? That the angle AC is equals to 65. So this is going to be 65, right? So you can draw the triangle like this, or you can draw the triangle like this. All right? So you can draw the triangle like this. All right? So with this one is that we know the fact that this is going to be A, B, and this is going to be C, right? So, but we're going to say A prime, B prime, and C prime, because this is the alternative of how you could draw this. And this is going to be 50 degrees still, and this is going to be what? 82, and this is going to be 65. Do you see the fact that that makes sense, right? You can have two different triangles, and which can result in two different answers, right? So with that said, we need to find angle C, right? So angle C is going to be what? It's going to be, so angle C here, we see the fact that this is angle C, and angle C is related to this one, right? And which one? Angle A has its side, which is this side. Do you see? So we can basically use that information. So we know the fact that sine C is basically divided by what? What is the side that is related to? Which is going to be AB. It's going to be equals to sine A divided by what? By B, C. Let's fill in the information that we're given. So we know the fact that sine C divided by AB, which is going to be what? Which is going to be 82. It's equals to what? Is equals to sine. Then A is what? A is 15 and it's related to 65. Cross multiply, so we're going to have sine we're going to have 65. When we cross multiply, we're going to have 65 sine C is equals to what? Is equals to sine 50, and this is going to be divided by 65, right? So we want sine C unknown, so this is going to be the same as sine C, right? Is equals to what? Is equals to sine 50 divided by 65, and this is going to be multiplied by what you call this. I made a mistake. Wait, this is cross multiply, so this is going to be 85. Let me just erase this part. There's a part where I think when we cross multiply, yes, because I feel like there is something that I did wrong. So when we cross multiply, this is going to be what? This is going to be 82 sine 50. That seems right. And this is going to be 65 sine C. That's correct, right? So now we want sine C unknown, so we're going to take the 65 to the other side. So it's going to be 82 sine 50 divided by what? Divided by 65 is equals to sine C, right? So when we do that, it's going to be what? It's going to be the same as having C is equals to arc sine, right? And it's going to be what? The third thing, which is going to be 82 sine 50 divided by what? Divided by 65. So when you punch that into the calculator, you're going to find the fact that angle C is basically equals to 75.1 degrees. But remember the fact that this is this angle, right? So this is going to be 75.1 degrees. So now we need this angle too, right? So we're not going to do the calculations. What do we know about the relationship? We know the following. We know that sine 180, right? 180 degrees minus C is basically equals to sine C. If that's the case, that means the fact that angle sine prime is basically going to be equals to 180 degrees minus angle C. So I just wanted to show you the fact that since we know that this relationship is that if we want this angle, it's basically saying 180 minus this angle. So sine A prime is basically equals to 180 degrees minus 75.1 degrees. Therefore, angle C prime is equals to what? Is equals to 104.9 degrees. So this will be your two answers, right? So it's going to be this one that you just found and this one that you just found. Just to not confuse you guys, is that after finding this one, to find the C prime is basically taking it's basically taking 180 minus the answer that you got, right? So just want to show you another thing is that if we wanted B, if we wanted A, right? If we wanted maybe A and B, right? Then to find B prime, it's basically going to be 180 minus B. So that's how you would find it. So after finding the angle that you're given, is that to find the prime of it is basically saying that what you call this 180 minus the angle that you got previously. I hope that makes sense. So now we're going to prove cos rule, right? So with cos rule, the first thing that we need to do is that we're going to do some constructions in the triangle. But before we do constructions in the triangle, is that we're going to rewrite the sides being the opposite, being the small letter of the angle, right? So this P, meaning the fact that this whole side, this Q, R is going to be P, small letter P. Then this R, the opposite side of it is going to be the small r, right? And let me just do like this. Then this Q, the opposite side is going to be the small q. The reason why I'm doing this is that with this proof, it's very easy for us to use these small letters to basically prove it properly, right? Because you're going to see the fact that we're going to need the small letters, because if I don't do that, it's going to be very confusing. So just make sure the fact that you will name the opposite sides by the angle, but small letters, right? So before that is that we're going to rewrite this proof, the one that we need to prove, in terms of what? In terms of the small letters. So let me just change my color so we can emphasize it. So we know the fact that PR is here. So this is going to be the same as saying Q squared is equals to PQ is R. So it's going to be R squared. Then it's going to be plus P squared, right? Minus is going to be 2R multiplied by P. Then it's going to be cos Q. The reason why I rewrote it like this is that when we prove, we need to see whether we are arriving to the answer or not. Because if I leave it like this, we're not going to know whether we are arriving to the answer or not. So that's sorted, right? So now let's move to construction. So let's do some construction. So with construction, do you know the fact that it's going to be the same thing that we did with area rule and sine rule? So this is going to be point is, right? So this being point is. Now we're going to name this small portion. So we know the fact that this is 90 degrees. So we're going to name this portion and we're going to name this portion. So we're going to name this small portion here as being is, right? So if this is and this whole thing here is P, so we know the fact that, let me just take my eraser. Okay, we know the fact that this is point is, right? So we know the fact that this whole portion here, and I just want to change the pen. The whole portion here is what? Is P, right? So if we know that this whole portion is P and the small portion here is S, we know the fact that now the small portion here is basically what? Is going to be P minus S. Because we're going to take this big portion minus this one small portion, it's going to give us the remaining. So that is sorted, right? So now we have our diagram filled in and ready to go. So now let's do what? Let's write the things that we did. So this is what we did. We're going to say construction, right? And with construction, we know the fact that draw, as in like the same thing, draw. It's going to be draw P, S, right? Then we know the fact that with S on Q, R, right? Then such that PS is perpendicular to what? Is perpendicular to QR. So that is sorted, right? So that is us doing what? The construction. Then now what I'm going to do is that in the diagram, do you see the fact that we have named the sides by the small alphabet? So that's what we're going to say. We're going to say let PQ be equals to R. Then we're going to say P R equals to Q. Then we know the fact that Q R is equals to what? Is equals to P. Then we know the fact that therefore the last one is what? And the last one is Q is equals to S, right? So we know that. So with that said, we know the fact that therefore that is going to result in what? That's going to result in S R being equals to P minus S. So that is sorted, right? So now, so what we're going to use is going to use theorem of Pythagoras, and we're going to find this small triangle and this big triangle, right? So using theorem of Pythagoras, what we're going to say in, so we're going to say in, let me just do it here, in triangle. Then we're going to start with the small one, which is going to be P, Q, S, right? We know using Pythagoras, because this is a right angle triangle, is that we know the following. We know the fact that R squared is equals to what? Because that's the hypotenuse, is equals to the sum of the two sides. So it's going to be S squared plus what? Plus, this is going to be H. So it's going to be plus H squared, because that's the height, right? Then we know the fact that in triangle P, PR then PR is, it's going to be what? It's going to be Q squared is equals to what? Is equals to opposite, right? Which is opposite is the, what you call this? It's going to be the sum of two sides. So it's going to be H squared. So it's going to be H squared, right? Plus what? Plus P minus S all squared. And the reason why we're using a theorem of Pythagoras because it has the Q squared, and this is what we want, the Q squared. I hope that makes sense, right? So we see the fact that looking at our information is that we have Q squared, and we see the fact that both of them, they have what? They have H, right? So we're going to make H the subject in both their cases, right? So that we can equate them. So taking the first one, and I'm just going to name it 1 so that we're not confused, and we're going to say 2, right? So taking 1, this is a lot. So let's do this so that we can have space. Yes. So taking 1, right, is that we know the fact that we're going to make H the subject. So this is the same as R squared minus S squared is equals to H squared, right? Then the other one taking 2, right? We know the fact that we need to make H squared the subject, so it's the same as Q squared minus, then open bracket is going to be P minus S all squared, right? And now since, and this is going to be equals to H squared. Do you see the fact that they both equals to H squared, meaning we can equate them together? So this is the same as Q squared minus open bracket. This is going to be P minus S all squared is equals to R squared minus S squared. Do you see the fact that we're becoming closer to what we want? This one. We have Q. So let's make Q the subject so that it can match us up with that. So we make Q the subject. This is going to be the same as Q squared is equals to what? Is equals to R squared minus S squared. Then this is going to be plus open bracket P minus S squared. So now we're going to expand this, right? So when we expand this, this is going to be the same as Q squared is equals to R squared minus S squared. Then this is going to be plus. When we expand this, so this is going to be the same as P squared, right? Then this is going to be minus 2 PS. So it's going to be PS. Then this is going to be plus S squared, right? Distribute the plus sign. So it's going to be Q squared is equals to R squared minus S squared, right? And this is going to be plus P squared. It's going to be minus 2PS, right? And this is going to be plus S squared. Do you see the fact that this one and this one are going to cancel each other? So we're going to be left with Q squared is equals to R squared plus P squared, right? Then this is going to be minus 2PS. Do you see that now we have Q, we have R, we have P squared, we have 2, then we have what? We have P. So now we need to get rid of S. So now we need to get rid of S. So let me just highlight that. We need to get rid of this S. So do you see the fact that this S is here, right? And do you see the fact that we need cos? Do you see the fact that if we use cos Q, we can have S and R, right? So we know the following. We know the fact that cos Q is basically equals to adjacent, and the adjacent is S divided by what? Divided by R, which is the hypotenuse. So making S the subject, this is the same as R cos Q is equals to S. So we're going to substitute this S by that. So this is going to be the same as Q squared is equals to R squared plus P squared minus 2, then P, then this is going to be R cos Q. Do you see the fact that this is exactly like this one? Do you see the fact that this and this are exactly the same thing? Because now we have R and we have cos Q. So now, therefore, we have proven that P R squared is equals to P Q squared, right? Plus P plus Q R squared, then minus 2P Q, then it's going to be QR, multiplied by QR, and this is going to be cos Q. So we have proven this. So that's how you would solve this question. So now we're going to do example 1 using cos rule, right? So cos rule works exactly how area rule works in terms of the fact that to solve it, it's going to be always two sides and the included angle, right? So now they say determine the side of QR, right? So as I said, the fact that it's to solve is that you always need two sides and an included angle. Or if they want the angle, let's say this was not there, but they gave us this, right? Is that we need to have all three sides, then that angle that we need. I hope that makes sense, right? So now we need what? We need a QR. So we see the fact that QR is related to what? Is related to this opposite side, right? Because let me just write this and let me just go here. Okay, cool. Let me write the formula for this one so that you can see the relationship. As I said, the fact that it's always going to be two sides in the included angle. So we know the fact that QR squared is basically equals to what? Is equals to the two sides, which is going to be PQ, right? Squared plus what? Plus, then it's going to be PR, right? Squared. Then this is going to be minus 2. Then this is going to be PQ multiplied by what? Multiplied by PR. Then this is going to be cos. Then this is going to be cos what? This is going to be cos P. Okay, so this is the relationship that I want to show you. Is that if they're looking for the side of something, right? This side, the one that's outside, needs to be opposite to the angle that is going to be in the cos. Then the two included angles is going to be this ones. That's going to be the two included angle, the two sides. Then the included angle is here. Then the relationship between these two is that this side needs to be opposite to the angle that you're looking for, right? So with that said, before we move on, is that I want to show you another thing. Is that I want to show you the fact that let's say maybe they gave us R, right? They gave us maybe the angle R and they're looking for this side. How are we going to do it? It was going to be what? Is that, do you see the fact that R is related to this? So meaning we need to start with PQ. So it's going to be PQ, right, squared is equals to, what is the two sides next to Q to R is this two sides. So it's going to be the same as what? It's going to be the same as PR squared plus QR squared minus 2. Then this is going to be PR. Do you see the fact that even here, this and this becomes here? It's going to be the one that's multiplying. So it's going to be the same thing. So it's going to be PR multiplied by what? Multiplied by QR. Then this is going to be cos. And what is the angle that's opposite to that side is R. Do you see that? So now let's move into if like maybe we're looking for Q, right? So the two, which whether it was two sides, which is going to be this one, and the angle that is the side that is opposite to that is going to be PR. So you will start saying PR squared is equals to, what is the two sides? The two sides is PQ plus squared. Then the other side is what? Is QR squared minus 2PQ, right? Then multiply by what? By QR. And this is going to be what? Cos. And the angle is what? Is this one. So that's how you would do it. I hope that makes sense. So with that said, now we can answer this question, right? So in our case is that they're looking for what? They're looking for this side, right? And this side, the angle that's opposite to it is P. So we see the fact that that is why we have QR and P as being the angle, right? So now let's fill in the information because of we have each and every information. We know the fact that QR is what we're looking for. So it's going to be QR squared is equals to what? Is equals to, then this is going to be PR is going to be 13. So it's going to be 13. So it's going to be 13 squared plus, then this is going to be 4 squared. This is going to be minus, then this is going to be minus 2. Then this is going to be 13. This is going to be 4. Then this is going to be cos, and this is going to be 70 degrees. Punch that into the calculator. You know the fact that QR squared is basically going to be equals to 149.42, right? Then square root both sides, so QR is basically going to be equals to 12.2 centimeters. So that's how you would solve this question. I hope that made sense. So now it says the fact that we need to solve angle A, right? So angle A is here, right? So do you see the fact that the side that is related to angle A is what? Is this one. And the nice thing is that they gave us all the sides, right? So it's related to this one. And since we're looking for angle A, the two sides is going to be this one that are going to be added. But the one that is related to it is this one. So our equation needs to start with this side that is opposite to the angle, which is the angle that we want. I hope that makes sense. So we're going to say BC squared is equals to what? Is equals to the two sides that are next to the angle, which is going to be AB squared plus AC squared minus 2. Then this is going to be AB multiplied by AC. Then this is going to be cos the angle that we want, which is A, right? So we know the fact that AB is 7. So this is going to be 7 squared is equals to AB. AB is what? AB is 5. So this is going to be 5 squared plus AC, which is going to be 8 minus 2. This is squared. Then this is going to be 5. And this is going to be 8. And this is going to be what? Cos A squared, right? So that's what we know. So what I'm going to do is that I'm going to expand this. So this is going to be 49 is equals to, when you say 5 squared plus 8 squared, it's going to give you 89, right? And when you say 2 multiplied by 5 multiplied by 8, it's going to give you negative 80. Then this is going to be cos A squared. Not cos A, not A squared. Then we're going to take the 85 to the other side. So it's going to give you what? When you say 89 minus 18, or you call this 49 minus 89, it's going to give you negative 40 is equals to negative 80. Then this is going to be cos A, right? Divide both sides by 80, negative 80. So it's going to be negative 40 divided by negative 80 is equals to cos A, right? So this is going to be the same as positive a half is equals to cos A. Now we want A alone, so this is going to be a cos, then a half is going to be equals to angle A. Punch that into the calculator, you're going to find the fact that A is basically equals to 60 degrees. And that's how you would solve this question. So now we're going to move to the application of trigonometry functions, right? Which is also the 3D diagram, right? So here, honestly, even like the situation, them talking about evolution and all that, it really doesn't matter. It's understanding what you're given in the diagram and what best formula to use. Remember the fact that the situation, even the paragraph, really doesn't matter, right? Is what you're given in the diagram, then knowing which formula to use. So now we're going to talk about first the sine and the sine rule, right? The formula. Then we're going to talk about the cos, right? Then we're going to talk about the area. The nice thing about the area is that they tell you find the area. So with that one, you don't need to be like, oh my God, which formula should use, but you need to know how to use it, right? But with the sine and cos rule, you need to know which one to use, right? So with that said, we have the following. So we're going to talk about the sine, right? Do you see the fact that it says what? It says sine A divided by A. Then you have sine B divided by, what you call this? Sine B divided by B, or is sine C divided by what? By C, right? So here, what matters is that you need two of this, right? So you either, if you're looking for an unknown, you know the fact that, let's say, for instance, B is unknown, and I'm just going to circle it, right? And let's say in the information that they gave you the following. And I'm going to highlight the information that they gave you, right? Is that they gave you, what you call this? They gave you A, right? And they gave you the angle A, and they gave you this A. And they also they gave you B. Do you see the fact that you have 3 information, right? Do you see you have 3 information and you would have 1 unknown? And how do you know that the sine rule is the one that's going to work? Is that from the angle, you need to have a corresponding side, right? Then here, do you see the fact that there's an angle and there's a corresponding side? So do you see the fact that this B relates with this corresponding side? And always draw the line that I'm doing, right? Is that this B correspond to this side, right? Then this A correspond to this side. So if you look at the information, if now we want to solve for B, it's simple. We can use the sine rule because we have 1, 2, 3 unknowns, and we want the one that we actually want, which is B, right? So that's how you would do it. So with this one, it would be what? It would be sine A divided by A, and it's going to be what? Sine B divided by B, right? So making B the subject, it will be the same as what? Cross multiplying. So it's going to be B sine A is equals to A sine B, which is the same as B is equals to A sine B divided by B. Do you see? And you have all the values here, or sometimes it will say in terms of something, or you have all the variables, right? So do you see the fact that that's how you would see it, right? So remember the fact that to know whether you're using sine, if you go from the angle, drawing a line, and you have that side, and taking another side, right? Drawing what you call is going from the angle, going to the side. If you see the fact that from the unknown, you have only unknown, then you can use the sine rule, right? So now that's how the sine rule you're going to use it, right? So let me just leave it here, right? So now let's talk about the cos rule. And I'm just going to do it with a different color with the cos rule. The cos rule, you need what? You need 2 sides and the included angle. Very important. It's 2 sides and the included angle, right? So what do I mean 2 sides? Let's say now we have C missing, right? And now to use the cos rule, you need how many? 2 sides and an included angle. So meaning they need to give you what? If this one is missing, they need to give you the following. And I'm just going to highlight it in green, right? They need to give you B. They need to give you A. And the included angle is C. Do you see the fact that why I'm saying included? Do you see the fact that B and C, the sides, the angle is in between the 2 sides that they gave you? Then if that's the situation, then you can solve for C. Do you see that? And if we go in the diagram this here, do you see the fact that is what you call this is C squared is equals to A squared plus B squared minus AB cos C, the included angle. So if this side is given, right, it's what you call this, it's missing. You need what? You need 2 sides and the included angle. And 2 sides and the included angle, that's the only way you can solve it, right? So this is going to be the one that's unknown. Obviously, it's going to be the one that's opposite. The side is going to be opposite to the angle, right? So remember the fact that if you have 2 sides and included angle and you want this, that's how you would solve it. And it's going to make sense when we do questions, right? So that's how you would use the cos rule, right? So this one, it's opposite sides, right? And opposite angles for the sine rule. Opposite sides, opposite angles. That's what you need to be given, right? Then with the cos rule is what is the included side, right? Is what is the 2 sides, sorry, is the 2 sides and the included angle, right? 2 sides and the included angle. So with area, yeah, with area, right, you're going to need the following. With area, you're going to also need the same thing that you need for cos. It's going to be, if they want the area of anything, like it could be any triangle and you're given, to find the area, you need 2 sides and included angle. So in this case here, do you see the fact that if maybe we given this one, and you need this angle. So you can find the area there, meaning it's going to be what? It's going to be a half, then you're going to say AB. Do you see that? It's going to be a half AB sine C. Do you see the fact that also area works with what you call this 2 sides and the angle that's in between the 2 sides. Okay? So that's how you need to understand basically how to basically work with the formulas. So now we're going to do the first question, right? It says point B, C, and E lies on the same horizontal plane, right? And they tell us the fact that ABCD is a what? Is a rectangle, right? It's a rectangular part of the board. And they tell us the fact that CDE is the triangular part of the board, right? Having a right angle, right, at C. So we see the fact that at C, we have the right angle, right? Then they say each piece of the board is placed perpendicular to the horizontal plane and joining along BC as shown in the diagram. So everything that they're talking about here is shown, right? Then they tell us the fact that the angle of evolution from E, right, to D is what? They tell us the fact that it's X. So we have the fact that that is X. Then they tell us the fact that BEC is equals to 2X. They tell us that. Then they tell us that EBC is equals to 30, which is labeled, which is nice because of they label everything, right? So now the first question, it says what? So let me just do this. The first question, it says, show that DC is equals to BC divided by 4 cos squared X, right? So every time when they ask you to show something, right? And with this one, they tell you what you need to show, right? You look at what they want from you and you write down the information, right? So what do we see? We see the fact that we're looking for what? We're looking for we're looking for DC. So we know the fact that we're looking for this one, right? So I'm going to just put a cross there, right? Now I'm going to mark here the things that they want, right? Our answer needs to be in terms of BC. So we see the fact that our answer needs to be in terms of this, right? So our answer needs to have BC in it, which is I just put a tick there. And also, if you notice, is that our answer, right, needs to have some X. Where is X? X is here. Do you see that? Right? And also X is where? So X is this one, and also X is where? X is here, right? Then looking at our diagram, right, we're going to look at the given information, right? So we see the fact that we given, and I'm going to highlight the given information because the given information tells us which formula to use. We see the fact that we have this 30, right, as the given information. We also have what? We also have this 2x that's given. We have this x, right? And that's it, right? And this 90 degrees things, right? So now remember the fact that we're looking for this one. And very crucial, we're looking for this one, right? So if we're looking for B, right? If we're looking for BC, right? And we look at the given information, which triangle between A, and I'm going to highlight it, right? I'm just going to highlight the two triangle that I'm talking about, right? Which triangle between the two? Which triangle between this triangle, right? Do you see this one? The right angle triangle. That's where, if you think about it, that's where we're going to get our BC because our BC is there, right? Compared to this triangle. So this triangle, the other one, right? This one. First, which triangle has more information? Do you see the fact that it's actually the green triangle, right? And the nice thing is that the green triangle has a part of what our solution should have, right? And what do we know? What is the relationship between the green triangle and the orange triangle? Do you see the fact that they share the same side? This is what they share. So do you see the fact that they share the same side? And this is the side that they share. Do you see the fact that this side is what they share, the one that I'm emphasizing? So from the green triangle, I can find this side, use this side, and use theorem of Pythagoras to basically find DC. So that's what we're going to do, right? So for 7.1, right, as I said, the fact that we're going to use the green triangle because of it has most information. From there, we're going to relate it to this orange triangle because of our length that we want is from the orange triangle. I hope that makes sense, right? But now looking, and I'm just going to take it out, right? I'm going to take out this green triangle and we're going to analyze it in terms of the information that they gave us, right? We know the fact that this is C, right? And this is E, and this is B, right? And this is 30. This is 2x, right? And this, we don't have it, right? So that's what we know, right? So looking at this, remember the fact that we want BC, right? We want what? No, we don't want BC. We want CE. And reason why we want CE, because of it's a common side, I can use that side to basically find what you call this DC, because of we're going to use Pythagoras rate, right? So I'm going to put a tick here, right? So looking at that, what information do you know? We know the fact that again, our answer, right? Our final answer needs to have what? It needs to have BC. So I'm just going to put this scribble like this, right? This needs to be part of our answer. So our answer can have this, right? So now looking at that, right? So let's say this is given. So this side is also given. So this side, it can be given because of our answer needs to be in terms of what? It needs to be in terms of BC, right? So now with that said, right? With me saying all that, right? So let me just take my pen. With me saying all that, right? So we know the fact that the green side is given. We know that the angle 30 is given. The 2x is given, right? So now let's relate. Let's first check out, can we do sine, right? If I do sine, if I do this, right? So I know the fact that this 30 degrees is going to link with CE, which is what I want. And we know the fact that this angle 2x is going to link up with what? With BC, which is what I want, right? So, and I want my answer to have BC. Do you see the fact that sine here would be the perfect one to use, right? Because if I had to use, what you call this? If I had to use what? If I had to use what you call this cos. Do you see the fact that I can't use cos because of I need this side and this side, right? And our answer does not have BE. So I can't even use this side. But we only need BC, right? So do you see the fact that, and the included angle, that one is perfect. But do you see the fact that our answer does not have BE? So we cannot use cos because of its two-sided and the included angle. Our answer does not have BE, but it have BC. So we can't use cos, but we can use sine, right? So with that said, we know the fact that it's going to be what? It's going to be the same as sine, right? And this angle here, which is this angle here, the 31. So it's going to be CBE, right? And that's going to be divided by what? When you draw a line across, it's linked to CE, right? And that's going to be equals to what? It's going to be equals to sine this angle here, which is CE, right? CEB. And that's going to be divided by what? That's going to be divided by when you draw a line across is linked to BC. So part of our question is sorted. We have a BC, right? So now we're just going to substitute values. So we know the fact that this one is the same as sine 30, right? So sine 30 degrees divided by CE is what I want because that's the common side, right? And that's going to be equals to, this one is going to be sine, then this is going to be 2x, right? And this is going to be divided by what? It's going to be divided by BC, which is what I want, right? So cross multiply, I'm going to have the following. I'm going to have BC multiplied by what? By sine 30 degrees is equals to what? 2CE. Then this is going to be sine 2x, right? So I want CE alone because that's the one that I want. So it's going to be the same as BC. Then it's going to be sine 30 degrees, right? It's going to be divided by what? It's going to be divided by sine 2x is going to be equals to CE, right? So that part is sorted. We have that, right? So we know the fact that this part is equals to what? It's equals to this value, right? So now we're going to go to this orange triangle, which is a right angle triangle. Do you see that? So we're going to go to that triangle, right? And this is D, this is C, and this is E, right? And this is 90 degrees, right? So remember the fact that we're looking for this, right? And now we already have the value of this, right? And this is X, right? So now with everything that I have, I can use what? I can use trig ratios to basically solve for this, right? So what do we know? We know the fact that since we want this and we have this, what is that? That is opposite, right? And this is adjacent. So this is opposite and this is adjacent. What's opposite and adjacent? That's 10. So this is the same as looking for 10, right? 10x, because this is x, the angle is x, is equals to what? Is equals to what's opposite is DC, what we actually want, divided by what? By CE, right? So now we know the fact that it's going to be 10x. We need to make what? DC the subject. So multiply that side. So it's going to be the same as CE is equals to what? It's going to be CE multiplied by 10x, right? Is equals to DC, right? So now with that said, I can substitute what? I can substitute this CE that we found, right? So this is going to be the same as saying BC, right? And this is going to be sine 30 degrees, right? Divided by what? Divided by 2x. And this is going to be multiplied by 10x, right? It's going to be equals to DC, right? So DC, I'm just going to write it here. It's going to be equals to, let's change this, no, let's not change it yet. The sign, right? I'm going to put an identity here. We know, I'm going to put an identity here. This is cos, this is sine, this is sine 2x, right? So I'm going to substitute an identity here and an identity here. So it's going to be what? It's going to be BC multiplied by sine 30 degrees. This is going to be multiplied by what? By what we have, it's going to be a sine x, right, divided by cos x, right? And this whole thing is going to be divided by the following. It's going to be divided by 2, right, sine x, right? So it's going to be 2 sine x, and it's going to be cos x, right? So this again is going to be what? We're going to have the following. So now we're going to have the following. So this, I'm going to change it now. So I'm going to get rid of the numbers because of sine 30 is a number in 2. So if I say sine 30 degrees, right, divided by 2, I'm going to get 1 over 4. So this is going to be the same as DC is equals to 1 over 4. So it's going to be BC. Then this is going to be multiplied by sine x cos x, right? And this is going to be divided by 4, right? Then this is going to be divided by 4. Then this is going to be what? This is going to be 4. Then this is going to be sine x. Then this is going to be cos x, right? So now, I don't have space. Let me just move in this direction. I'm going to start way here, right? So with that said, I'm going to take this one and I'm just going to divide it here, right? So this is the same as saying B DC, right, is equals to what? Is equals to the following. It's equals to, when I say B C, right, multiplied by what? By sine, right, sine x divided by what? By cos x. And let's just do this actually. Not to complicate things, since here this one is the numerator, so I'm going to multiply BC, right? So I'm going to multiply BC with what? With sine x. So it's going to be sine x like this, and this whole thing is going to be divided by cos x, right? And that is going to be what? It's going to be the same as divided by, when I change this one, it's going to be what? It's going to be divided by 4 sine x. Then this is going to be cos x, right? So that is the same as changing this one, since it's in the numerator. It's the same as saying DC is equals to B C multiplied by sine x divided by what? Divided by cos x. And this is going to be multiplied, since it's in the numerator and the denominator is 1. It's going to change and it's going to be what? It's going to be 1 divided by what? By 4 sine x. Then this is going to be multiplied by cos x, right? So do you see the fact that since it's multiplication, the signs are going to cancel out? So your answer here in the numerator, you're going to be left with BC divided by what? By 4 cos squared x, which is exactly what they want. So that's how you would do this question. So now we're going to do 7.2, right? So we're doing 7.2. It says what? If x is equals to 30 degrees, show that the area of ABCD, right, is equals to 3AB all squared, right? So now we're going to do that. So let's do the following. So we're looking for the area of, I'm going to highlight why we're looking for the area. So we're looking for the area of this rectangle, right? So this rectangle is the area that we're looking for, right? And I'm just going to take it out from there, right? Because I like working with things outside them, right? So if I look at this, so I can evaluate the information that I'm given, right? So we're looking for this area of this triangle. So this is going to be A, this is going to be B, this is going to be C, and this is going to be D, right? So this is going to be D. Yes, D, right? So we are given the fact that BC, which is this one, right? We know the fact that DC is equals to what? Is equals to BC divided by what? Divided by 4, what? 4 cos squared x. But we know that x is 30, right? So it's the same as DC is equals to BC divided by what? By 4 cos squared 30 degrees, right? So punch that into the calculator, the 4, right? Open bracket and say cos 30 degrees, then all squared is going to give us what? It's going to give us 3. So we know the fact that not BC, DC is equals to BC divided by what? Divided by 3, right? So do you see the fact that our answer needs to have AC? So we know that AB. So our answer is going to be this. Then we're going to need this length here, right? Our answer needs to be in form of AB. So that's sorted. So that's like given. Then it needs to have BC. But what do we know about the relationship about BC? Is that we know the fact that DB is equals to what? Is equals to BC divided by 3, right? So now I can take 3 to the other side. So it's going to be 3. DC is equals to what? Is equals to BC, right? So we know the fact that this one is going to be equals to 3BC. But what do I know about BC, right? Is that, do you see the fact that since this is a rectangle, we know the fact that those two sides are equal. So I know that, and I'm just going to write this, right? I know the fact that AB is equals to DC. And that's because of this is a rectangle, right? Opposite sides are equal. So if that's the case, now I can basically find the area of this side. So what's the area? So the area, right, of, because I have this side, right? And I have it in terms of what? I have it in terms of BC, right? Because I know the fact that if this is AB, so this is going to be the same as 3AB. Because remember the fact that AB and BC is equal to each other. So this is going to be the same as that, right? So now with that said, I can find the area of what? Of A. So of A, B, C, D, which is going to be the same as length times breadth, right? So it's going to be what? It's going to be, our length is AB. So our length is going to be the same as AB, right? Multiplied by what? By BC. So it's going to be multiplied by BC, right? But we know the fact that BC is equals to 3AB. So that's going to be AB multiplied by what? By 3 times AB, right? So our answer here is going to be 3AB squared, which is exactly what they want. And that's how you would get your 3 marks. So now let's do question 2, right? It says, a landscape artist plans to plant flowers within 2 concentric circles around a vertical line pole PQ. So we see that there is a vertical line PQ. R is a point on the inner circle. So we see the fact that R is a point of the inner circle, meaning the circle that's inside, and on the inner circle. And S is where? So they tell us the fact that S is a point on the outer circle, so it's outside, right? And they tell us that Q and S lie on the same horizontal plane. So they tell us that Q and S, right, lies on the same horizontal plane. And they tell us more the fact that RS, right, is the pipe used for the irrigation system in the garden, right? So they tell us the fact that the radius of the inner circle is the small r, And they tell us the fact that the radius of the bigger circle is QR, so it's this one, right? Then they tell us that the angle of evolution from S to P is 30 degrees, which is written. Then they tell us the fact that RQS is equals to 2x. Again, it's given here. Then they tell us the fact that PQ is equals to square root of 3R, right? So with that said, now with all the information that they gave us, let's go and answer the questions, right? So 7.1, it says show that QS is equals to 3R, right? So meaning whatever we do, we need to make sure the fact that QS is equals to R, right? So now where's QS? So we know the fact that QS is this one. Do you see that? Is this one, which is the radius of the what? Of the bigger circle, right? So we see the fact that this is within this triangle. Do you see the fact that is within this triangle, right? So if I had to redraw this, right? I like redrawing because of I get to see the information properly, right? So this is P, this is Q, and this is R. And this is 90 degrees, right? So we are given that this one is 3R, right? And we're looking for what? We're looking for this side, right? And we are given the fact that this one is 30 degrees, right? Do you see the fact that I can use trig ratios to basically solve this one, right? So from this side, I know the fact that this is opposite to one given side, which is this one, and the one side that we want, which is QR, is this one. So if this is opposite and this is adjacent, then what are we going to use? We're going to use 10, right? So here it's going to be 10. What is our angle? It's 30 degrees. So it's going to be 30 degrees is equals to what? Is equals to opposite, which is going to be what? Which is going to be PQ divided by what? By adjacent, which is going to be QR, right? So now we want QR as the subject. So we're going to multiply it first. So it's going to be QR multiplied by 10. 30 degrees is going to be equals to PQ, right? So divide both sides by, by 10, 30, because I want QR alone, right? So this is going to be the same as what? As QR, not QR, man. It's not QR, it's QS. So this whole time I've been saying QR. So this is QS, right? I'm looking for QS. So this is QS, right? So this is going to be QS, right? So this is QS. Even here, let's just fix that. This is QS, right? So this is going to be QS, right? So this is going to be QS. So this is going to be QS 10, right? 30 degrees. So it's going to be basically QS. Want that to be the subject. So it's going to be QS. Right, so it's going to be QS is equals to PQ divided by what? By 10, 30 degrees, right? So now we already know what's PQ, right? PQ is what is 3 root R. So we know the fact that this is going to be QS is equals to root 3 R. And this one, when I find it in the calculator, it's going to be what? It's going to be 10, 30 degrees, which is I'm going to get root 3 divided by 3. So this is going to be the same as what? As Q is equals to what? Is equals to, when you say root 3, right? Divided by what? Divided by root 3 divided by 3. You're going to get your answer as big 3. So this is going to be exactly equals to 3. Then this is going to be R. So which is exactly what they want from you, right? So that's how you do 7.1. So now moving to 7.2, they tell you the following, right? They tell you the fact that determine in terms of R, right, the area of what? Of the flower garden. Where is going to be the flower garden? Let me erase this. The flower garden is the following, right? Flower garden is the following. It's this. Do you see the circle? The one in blue. That's the flower garden, right? So how would you determine that area, right? So the area of the flower garden is going to be big circle. So area of the garden. So I'm going to say area of the flower garden of flower garden, right? is equals to what? It's going to be equals to the area, right? So it's going to be the circle area of the big circle minus, which makes sense. So you find the area of the big minus the small, which gives you that region, right? So it's going to be area of big minus area of small, right? So since the area we're dealing with circle is the same as pi r squared of big minus pi r squared of small, right? So remember that the radius of the big circle is what? It's actually QS. So this is the radius of the big circle, and the radius of the small circle is just what? It's just this r, right? Which is RQ. So we know the fact that it's going to be pi r. Our r, let's substitute, is, as I said, the fact that is QS. So it's going to be 3r all squared minus the radius of the small. So it's going to be the same as pi r squared, right? Because it's r. So here we're going to have the fact that distribute the square. This is the same as 9, right? 9 pi r squared. And this is going to be minus pi r squared. So this is, because they are common, we have pi r squared and pi r squared. So when we add them together, it's going to be 9 minus 8, which is going to give us 8 pi r squared. And that's how you would answer this question, right? So now, moving on to question 7.3. It says show that RS, so let's find RS first. We're going to highlight it, right? So let me just highlight it with a different color. Where's RS? RS is going to be this one, right? It says show that RS is equals to 10 minus 6 cos 2x, right? So we see the fact that our answer has what? Has cos 2x. So meaning this needs to be there, the cos 2x, right? And the nice thing is that we know the fact that this section is r and this section is what? Is given as 3r. So I can use this triangle, this yellow one, the one that I'm highlighting right now, to basically solve for RS, right? So I'm just going to replicate it here. So this is going to be 7.3. So if I'm going to have this triangle like this, so I'm going to have the following. This is going to be Q, right? This is going to be R, and this is going to be S, right? Remember the fact that we're looking for this one, right? So we have 2x here, right? Then here, remember the fact that we have R and we have calculated QS, which is what? Which is 3R, right? So now let's look at the information that we're given, right? Let's check whether can we use sine. With sine, remember the fact that it's linked to this one. If I use sine, is that I need this one, right? Which is sorted. Then either between R and 3R, I need an angle. Do you see the fact that, this one, we don't have an angle, right? Even this one, if we use this R, do you see the fact that we don't have a R and we don't have angle R, we don't have angle S? Do you see the fact that sine is not going to work here? So here, sine is not going to work, so I'm going to erase that. Because do you see the fact that when I draw lines from the angle to the side, we only have the side, right? And even here, we only have the side, right? So now we're going to move to what? We're going to move to what? We're going to move to checking whether can we use cos, right? So with cos, what do we need? We need, since we need this side, we have its angle, so that's sorted. But we need the two included side, right? Do you see the fact that we given R and we given 3R, right? So because we have calculated that. So we can use cos there, right? So remember the fact that we're looking for RS, right? So it's going to be RS squared is equals to the two sides. So it's going to be QR squared plus what? Plus QS squared. And this is going to be minus 2. Then there's two sides again. It's going to be QR, right? Then here's going to be QS. Then it's going to be cos. Then the included angle, which is I'm going to just substitute as 2x, right? Because I'm kind of lazy to rewrite it as the actual angle, right? So now let's substitute the values here. So we're going to have the following, right? So we're going to have the fact that QR is the same as R squared. Then this one is the same as 3R all squared minus 2, then this is going to be what? R, and this is going to be 3R, then this is going to be cos 2x, right? So now we're going to have the following. We're going to basically simplify this. This is going to be R squared plus 9R squared. Then this is going to be what? Negative 2 multiplied by 3, which is going to give us what? Negative 6R squared. And this is going to be multiplied by cos 2x, right? Add this together, we're going to have 10R squared, right? And this is going to be what? Minus 6R squared. Then this is going to be cos 2x, right? So this is going to be R squared, then this is going to be rs squared, right? So now we're going to take out r as a common factor, so it's going to be rs squared is equals to r squared, open bracket, we're going to have 10 minus 6, then this is going to be cos 2x, right? So now with that sorted, right, this is going to be what? We're going to square both sides, so this is going to be rs is equals to the square root of everything here. So it's going to be what? It's going to be r squared, then open bracket is going to be 10 minus 6 cos 2x, right? So since we have a square root and these two are multiplying, I can distribute the square root. So this is going to be the same as the square root of r squared, right? And this is going to be the same as the square root of 10 minus 6 cos 2x, right? So here our answer is going to be the square root and the square is going to cancel out. So you're going to have r, then this is going to be inside the square root of what? Of 10 minus 6 cos 2x. So now we know that rs is equals to that. So we got exactly what they wanted, right? So now we're going to move to what? We're going to move to 7.4. It says if r is equals to 10, right? 10 meters, and x is equals to 56, calculate rs. So taking this one, so for 7.4, taking this rs, so we know the fact that rs is equals to, they gave us r, which is going to be 10, right? Then it's going to be the square root, then it's going to be 10 minus 6, then this is going to be cos, then it's going to be 2 multiplied by x is equals to 56, right? Then if you punch that into your calculator, you're going to get your answer as being what? You're going to get your answer as being the following. It's going to be equals to r is going to be equals to 34,9, right? So which is approximately, rs is going to be approximately equals to 35 meters. So that's how you would answer this question. So now we're going to do question 3, right? It says what? It says in the diagram below, shows a solar panel A, B, C, D, which is affixed to the flat piece of the concrete slab, right? Then they tell you the fact that EFC, right? So it's fixed on that gray part, which is the concrete slab, right? And they tell you the fact that A, B, C, D, and EFC are two identical, meaning they are exactly the same thing, right? Two identical rhombus. What is a rhombus? Is a square that is sliced, meaning opposite sides are equal and everything is equal. So since with that information, since we know the fact that this side is x, do you see the fact that we're given that this side is x? That means this is going to be x. That means this is going to be x. That means this whole side here is going to be x. I'm just going to put it here. Then that means that this side is going to be x. This one is going to be x, and this one is going to be x, right? And this, since, do you see the fact that there's a midpoint, meaning this is going to be a half x, and this one is also going to be a half x, right? I'm just putting the information since we're talking about a rhombus, and they tell us the fact that K is a point on DC. So it tells us the fact that K, right, is a point on DC such that DK, right, is equals to what? 2KC. So K is the midpoint, right? As I already filled in, because of half of X is going to be basically X divided by 2. And X divided by 2, when you add them together, you're going to get half. You're going to get 1, which is going to be the entire this thing, right? Then they tell us the following information. They tell us the fact that AK is perpendicular to DC, which is they already have it here. So even this side is going to be 90 degrees, right? Then they tell us the fact that AF and KF are drawn. Then they tell us the fact that ADC is equals to what? Is equals to CDE. So is ADC. So the 60 is equals to what? Is equals to, where C is here, C D, so it's going to be CDE, no. So this one is already labeled, so it's going to be A, which is this one. It's going to be equals to A, right? Then that's going to be D, and then so it's going to be ADE, right? So that's already written there, right? So we know the fact that these two are both equals to 60. Then they tell us the fact that AD is equals to X, which is we already put all the necessary information that is equals to X, right? So now moving to the first question. It says determine AK in terms of X. When they say determine something in terms of X, it should be no other variable besides X, right? So let's check what they want. So I'm going to highlight what they want. So what do they want? They want AK. Where is AK? It's here. It's this one, right? Do you see the fact that AK is where? It's here in the right angle triangle, right? And the nice thing is that this right angle triangle has all the information that we need, right? So again, I'm going to reproduce this. So we're going to have this triangle like this. And this is A. This is K, right? And this is D, right? So we know the fact that this is 60, right? This is a 90, and this is X, right? And what are we looking for? We're looking for AK. So we're looking for this one, the one that I put a tick, right? So related to that, obviously our angle is going to be this one. So it's going to be opposite, then over hypotenuse because it's opposite the square, right? So it's going to be opposite over hypotenuse. So this is the same as, which one has opposite over hypotenuse? So this is opposite and this is hypotenuse. It's sine, right? So we're going to have sine 60 degrees is equals to what? Is equals to opposite. Our opposite is A. K, what we want, divided by what? By A D, which is X, right? So take the AD to the other side. So it's going to be A D, right? And it's going to be sine 60 degrees, right? It's going to be equals to A K. So AD is X. So this is going to be X sine 60 degrees is equals to A K. So therefore AK, if you substitute what? If you substitute sine 60, it's going to be equals to, it's going to be equals to the root 3 divided by 2. Then this is going to be what? Multiplied by X. So do you see the fact that our answer AK is only in terms of X, right? So now moving into 7.2, they want us to write the size of what? Of KCF, right? So they want us to write the angle of K, where's K? It's here, C is here, and F is here. So this is the angle that they want, right? So this is a rhombus. What does it mean? It means the fact that opposite sides are also parallel, right? So since the opposite sides are also parallel, what does it mean? It means the fact that, do you see the fact that we have a property of what? And I'm just going to highlight it. Going to highlight that. So we have a property of what? Of co-interior, right? What do we know about co-interior angles? They are supplementary. So now if I say what? If I say angle, right? So if I say, so let's say since, right? Since DE is parallel to what? Is parallel to CF, right? What do we know? We know the fact that this angle here, and I'm going to name it, which is going to be ED and C plus this angle here, right? The one that we want, which is going to be KCF is going to be equals to 180 degrees, right? And I'm just going to write this. Reason is not compulsory. I'm going to write the reason for you guys so that you can know why we're saying that. That's co-interior angles, right? Okay, interior angles are supplementary, meaning they add up to 180 degrees, right? So this is going to be 60, right? And this is going to be plus what we want, which is KCF is going to be equals to 180 degrees. Take the 60 to the other side, it's going to be KCF is equals to 180 minus 60, which is going to give you 120 degrees. So we have that as 120 degrees, right? So we sorted with that one. Then the last question, which is 7.3, it says the following. Let's just do it here if we need more space, right? So with 7.3, it says the following, right? It says, if it's further given that AKF, right, the angle between the solar panel, right, and the concrete slab, right, is Y. So we know the fact that what you call this A. So let's go find that A. So A is here, right? A and then AK. So it's going to be what? Which angle is going to be AKF, right? So this whole entire angle, right? So they're saying this entire angle is equals to Y, right? Then they say determine the area of the triangle A. So I'm going to highlight the triangle before I take it out, right? So let's highlight the triangle before we take it out. So the triangle A, we want the area of the triangle A, which is here, which is K is here, and what? And F, which is here. So we want the area of this triangle. Right? So this is the area of the triangle that we want. Right? So that's the triangle that we want, right? The area of that. So now let's basically draw that triangle. So this is going to be like this, right? So this is going to be, why am I slanting it? So this is going to be straight like this. So it's going to be like this, and this is going to be like this, and this is going to be like this, right? And then it has a couple of components. Remember the fact that it has the C, and I'm just gonna probably need it. So I'm just gonna, we know the fact that this is C here, and this is 120, right? And we know what? We know the fact that this whole thing is Y, right? And we need to determine what? Determine the area in terms of X and Y. So this Y needs to play a role, right? So we know the fact that this is A, K, and this is F, right? So what do we know? We know that this portion here is half. Remember the fact that it's half. KC is a half X, right? And what do we know again? We know the fact that this whole CF is X, right? So now with area, if we need to use this Y, we need this side and we need this side, right? Because it's two sides and the included angle. So now we have this side, right? We already know what is AK. We know the fact that AK is equals to root 3 divided by 2x. But the problem is this one, right? Is KF, right? So we see the fact that KF is within this triangle. And I'm going to just reproduce it, right? And I'm producing it so that you can see it properly. No eraser, right? So it's within this triangle, right? It's within this triangle here. The one that we found there, 120. So this is going to be 120. Then this is going to be a half X, right? And this is going to be what? It's going to be the side, which is going to be just X. So do you see the fact that with this one, and we want this section, because we want this KF and this is C, right? We want this KF because of this KF is one of the side for the areas, right? So we need to solve for this. Then after solving for this, we can basically solve for the area. So let's solve for this side. So you can substitute and solve for the area. Now, so now what we're going to do is the following, right? So let's solve for this, right? So what do we see? We see the fact that we have this and we have its angle, right? Do you see the fact that we have the angle and the included side, right? So that's perfect. So what does it mean? We can use what? We can use the cos rule, right? Because we have two included side and the angle and the side that we want, right? So this is going to be equals to what? It's going to be equals to K F squared is equals to what? Is equals to C F squared, right? And this is going to be plus CK squared, right? And this is going to be minus 2 CF, right? then C multiplied by C, K, then this is going to be cos of the included angle. So this included angle is going to be what? It's actually KCF, right? Substitute everything. This is going to be KF squared is going to be equals to what? It's going to be equals to the following. It's going to be, this one is going to be X squared, right? And this is going to be X divided by 2 all squared, right? And this is going to be minus 2, then this is going to be X, and this is going to be X divided by 2, and this is going to be cos, then this is going to be 120 degrees, right? So now with that said, right, it's going to be KF squared, this is going to be X squared, and this is going to be X squared divided by 4. Then here's going to be what? The negative 2 multiplied by a half is going to be basically 1, so it's going to be minus, then this is going to be X squared, and this is going to be cos 120, right? So let's find cos 120, right? So we're going to say KF squared is equals to X. When you say X squared plus 1 over 4, you're going to get 5, right? X squared divided by what? Divided by 4, right? And this is going to be minus X squared. When you find cos 120, it's going to give you negative 1 over 2, right? So this is going to be the same as what? This is going to be the same as 5 over 4 X squared. Then a negative and a negative is going to give you a positive. Then this is going to be X squared divided by 2, right? So this is going to be equals to what? So your answer here is going to be equals to, add them together, is that we're going to have that, what you call this, KF squared is going to be equals to 7, right? 7x squared divided by what? Divided by 4, right? But remember that we need the following. We need just KF, right? So KF is going to be equals to the square root, right, of what? Of 7x squared divided by 4, right? So that's going to be equals to root 7, then it's going to be x, right, divided by what? Divided by 2. So this is going to be what? KF is going to be equals to. So now let's just go to the next page. What I mean is going to be like this. So we're going to have, I'm just going to redraw this diagram. Now having your KF. So we know the fact that AK, right? We know the fact that AK is root 3x divided by 2, right? So this is AK, right? We know that this whole thing is Y, right? And we know the fact that this is F, and we already calculated this. And when we calculated it, we had root 7 over 2. So we had root 7 over, let's go up again, x divided by 2, right? So now we have that, right? So what is the area of this? Remember, it's what you call this, 2 sides and the included angle. So this is going to be the same as the area of triangle. Let's name it. It's going to be AKF. It's going to be equals to the following. It's going to be equals to a half. Then it's going to be the size that we have, which is going to be AK multiplied by KF. And the included angle is what? It's going to be sine Y, right? So now it's going to be what? It's going to be a half. Then AK is what? AK is going to be root 3, right? X divided by 2. Then this is going to be what? This is going to be root 7, right? X, and this is going to be divided by 2. And this is going to be sine Y, right? So now that means that your area is going to be what? It's going to be the square root of 21 x squared, right? Then it's going to be sine Y divided by what? Divided by 8. So this will be your area.